I think in this century, we'll probably pick up signals from an extraterrestrial civilization.
To learn more about the universe beyond our solar system, NASA sent the Voyager 1 probe into space in 1977. They had no idea that their tiny spaceship would go on to become one of the greatest and most exciting feats in human space travel, one that would be able to forever mark an era in the collective imagination and inspire future generations. Its findings have widened our knowledge of the solar system's furthest reaches, and it continues to yield new insights into the cosmos. The probe's continued journey through space encapsulates human curiosity and our yearning to discover the uncharted. However, NASA's Voyager 1 spacecraft recently had an odd encounter with an unidentified space object, leaving physicists perplexed. Who or what has Voyager 1 contacted? How long will this spacecraft remain in orbit? Let's find out. A Titan III Centaur rocket carrying Voyager 1 lifted out from Cape Canaveral in Florida on September 5, 1977. Its purpose was to photograph the planet's moons and research Jupiter and Saturn, focusing on the Titan satellite, its magnetic fields, and its rings. But it ultimately covered a lot more ground than that. The spacecraft, which is roughly the size of a small vehicle, is loaded with numerous scientific tools, all of which were state-of-the-art in their respective fields at the time, such as cameras, spectrometers, and plasma detectors with the purpose of gathering information about the planets it visited. The probe was launched and spent the following 2.5 years traveling to Jupiter, where it made its first significant finding. On March 5, 1979, the probe made a pass by the gas giant and continued to take pictures of the planet until April. A little while later, Voyager 2, the sister probe, was in turn. Numerous discoveries were made about Jupiter and its moons by the two Voyagers. The finding of sulfur volcanoes on Io, which had never been seen from Earth or by Pioneer 10 or Pioneer 11, was the most unexpected. The four largest moons of Jupiter, Io, Europa, Ganymede, and Callisto, which are commonly referred to as the Galilean moons, were then found to be part of a complex system of moons around Jupiter. In addition, Voyager 1 found that Jupiter had strong magnetic fields and radiation belts, which may be hazardous for any spacecraft that traveled too closely. The spacecraft made new findings while traveling toward Saturn after finishing its mission at Jupiter. On November 12, 1980, as it passed just about 75,000 miles from the planet, the object made its closest approach. The probe found that Saturn had many more moons than previously believed and had hundreds of rings, each of which was composed of thousands of tiny particles. Titan, the moon of Saturn, was found to have an atmosphere by Voyager 1, making it the only moon in the solar system to do so. Voyager 1 finally left our solar system in 2012. It then made history by becoming the first artificial object to go into interstellar space, which is the region between stars. More than 13 billion miles away from Earth, it is still sending data back to researchers and revealing important details about the structure of the cosmos. Voyager's entry into this new region, where impacts from the rest of the galaxy become more obvious, was first anticipated by scientists to be gradual and uninteresting. Then the peculiar zone turned out to be far more intricate than anything they had anticipated. The solar wind, which is ejected supersonically from the sun's atmosphere at a speed of more than 620,000 meters per hour, is a plasma of charged particles. Some of these ions are propelled outward at speeds of up to 10% of light. The solar magnetic field is also carried by these particles. This wind is believed to eventually reach the interstellar medium, which receives a totally distinct flow of particles from the deadly explosions of big stars. Galactic cosmic rays are the name for the incredibly energetic ions produced in these bursts, and the solar wind mostly prevents them from entering the solar system. The magnetic field of the galaxy is estimated to be at a substantial angle to that of the Sun. Voyager 1 entered the solar wind's edge in 2003, according to research, because the spacecraft's detectors showed that the particles around it were traveling subsonically after having slowed down after departing from the Sun. Then, a year or so ago, the probe's immediate environment became incredibly quiet. The solar wind abruptly decreased by a factor of 1,000, to the point where Voyager 1's equipment suggested it was almost invisible. This change happened really quickly, in just a few days. The readings of galactic cosmic rays also considerably rose during the same period, which would be just as we expected if we were outside the solar wind, according to Caltech physicist Ed Stone, the project scientist for Voyager and the primary author of one of the science studies. Voyager 1 almost appeared to have escaped the sun's sphere of influence. What then is the issue? Well, galactic cosmic rays ought to be pouring in from all directions if the solar wind has fully disappeared. Voyager discovered them instead of coming primarily from one direction. Furthermore, the probe hasn't detected any significant changes in the magnetic fields around it, despite the solar particles having decreased. Given that the galaxy's magnetic field is assumed to be inclined by 60 degrees with respect to the field of the sun, that is difficult to explain. The probe also detected the interstellar space's own signature, a weak plasma hum that researchers liken to light rain. Starting in 2012, researchers have focused the spacecraft's equipment on a region of far-off space that has never been probed before. The interstellar medium that envelops our small neighborhood can no longer be held back by the solar wind, the continuous stream of charged particles that flows off the sun at the heliopause, where Voyager 1 crossed. Since 2012, Voyager 1 has been measuring the plasma surrounding the sun as it has strayed further and further from it. Most of the time, this region of the interstellar medium is calm. The new research's principal investigator, Cornell University PhD student Stella Koch-Acker, said in a statement that the signal is very faint and monotone because it is in a narrow frequency bandwidth. We are picking up a constant faint buzz of intergalactic gas. However, the solar wind pushes back every few years. These occurrences are detected by Voyager 1 as shockwaves. Senior author and Cornell University astronomer James Cordes compared identifying a solar outburst to finding a lightning strike in a thunderstorm. After that, it resumes raining lightly. Scientists first believed that Voyager 1 could only estimate the density of the plasma outside using those shocks. However, now that they have detected this unexpected hum, scientists are able to monitor the interstellar medium in between shocks, which will allow them to learn much more about a still mostly unexplored region of space. Acker thinks there is a lot more low-level activity than previously imagined in the interstellar medium, but even for a spaceship, aging has its own set of challenges. The probe last year encountered a problem with its Attitude Articulation and Control System, AACS, the system that keeps its antennae pointing toward Earth without any known interference in its previously flawless record. The confused probe started sending back inaccurate telemetry data through an onboard computer that had stopped working years previously, distorting the correct data as it became confused about its location in orbit. Voyager's blunder raises the question of whether it is time to retire one of NASA's oldest and farthest traveling space probes, despite the fact that engineers were recently able to resolve the problem by instructing the system to revert back to its previous computer. Although the organization states that the inaccuracy doesn't pose a risk to the mission's long-term viability, some scientists have already begun working on developing Voyager's apparent heir. We've gotten incredibly lucky with the Voyagers, and so the fact that the things are still working as well as they are is really a combination of technological miracle and some luck, says Ralph McNutt, the chief scientist for space science at the Johns Hopkins University Applied Physics Laboratory. So if things go wrong, it's not surprising. Depending on when it can receive a gravity assist from Jupiter, McNutt's probe proposal might be ready to launch between 2036 and 2042 with the correct technology. The orbit of the vehicle would use the planet's gravitational pull to slingshot itself into space's furthest reaches. If Interstellar Probe is successful, it may surpass its predecessor's record for being the universe's most remote man-made object. In addition, Interstellar Probe would be durable enough to last for at least 50 years, unlike the 45-year-old Voyager, which has outlasted its initial mission lifetime by a factor of 10. A hypothetical launch, though, would be years away. The proposal is still in its early stages, despite NASA funding the initial study. It won't become an official mission until it has been examined and chosen by a decadal survey committee whose recommendations might take another 2 years to be finalized. But why precisely are probes necessary when astronomers have access to potent observatories like the James Webb Space Telescope and the eagerly anticipated Nancy Grace Roman Space Telescope, which will seek dark matter? The straightforward explanation is that the missions frequently have differing priorities and capabilities. While JWST and Roman are astrophysics projects that research things like exoplanets and distant galaxies, Voyager and the Parker Solar Probe are heliophysics